Okay, Calc. This is I'm with a kid at an appointment today, so we are the last half of section 2-3. Here's the homework assignment for it. I think the other day you should have done maybe 2 through 10, and maybe even number 18 with this. So we're doing the power rule on this, although we don't know that it's called the power rule. I don't think yet. Oh yeah, we do, the power rule on this, which is that n x to the n minus 1. We're learning derivatives, the shortcut rule for derivatives. Okay, power rule. We are on example, I think, 7, but before we do example 7, I want to backtrack just a little bit, and I wrote these examples down if you want to do those, or just watch me do them. But here's this. This first one is example with a polynomial, and we're trying to find the derivative of him. So we just take each piece separately, like bit by bit, right? So this first one, we drop the 2 down in front, and that will be -8 x to the, and I subtract 1 from the 2, so that will be x to the first power, or just x, right? Okay, this guy's x is x to the first power, so I'm going to drop the 1 down in front. 1 times 7 is 7, and now he is x to the 0 power, and x to the 0 power is 1, so he's just gone, right? We learned the other day that if you were taking the derivative of something that just has an x on the end of it, it's just that constant in front, right? And then this one is like x to the 0 power, so 0 times that is going to knock the whole thing out. So a constant is going to just go away. So here is your derivative of that stuff, okay, just that polynomial right there. All right, now there's another one that's a little bit harder, and this is an example, and I wanted to do this one real quick because I want to show you that sometimes we have to fix him before we can actually find the derivative. Okay, so what I'm going to do is I'm going to take this x to the third from the bottom, and I'm going to move him to the top. Now, a lot of people try to move the 3 with it. No, you can move the x by itself, right? So if I move him to the top, it's kind of like moving him to the side. I'm going to leave that 1/3 just chilling, and this is going to be x to the -3rd. So he's like on the top, but I've like shifted him to the side because it's going to be really easy for us to see this. If I bring the -3 down in front, right, -3 times 1/3 is going to be -1, x to the, and if I'm subtracting 1, that's going to be -4, right? Now I'm going to fix this thing again, and I'm going to push him back down below, so he will be -1 on top over x to the 4th power. There's that. Okay, now if you have radicals, like this is the 4th root of x, we have to fix him first. We have to make him an exponent, and he will be x to the 1/4 power. All right, now I'm just going to do all the same things. The 1/4 is going to come down in front. X to that, if I subtract 1 from 1/4, that will be like subtracting 4/4, right? 1/4 minus 4/4 is -3/4. Okay, and then I'm going to push him back underneath, like with the 4, right? I always put him back underneath with that number, and then he will be x to the +3/4, or 1 over 4, and that is the 4th root of x cubed, is what he looks like. Okay, so there is that. All right, that is kind of just like a little quick review of the stuff that we did the other day. All right, now I'm going to show you the magic of like why this maybe is helpful when you're trying to find things, okay? So it says, at what points, if any, okay, does the graph of this thing have a horizontal tangent line, okay? Horizontal tangent line. Now, if I'm looking, you won't always have the graph. Like on the homework assignment, you won't have the graph. But this is the graph of what he looks like. And we notice that like a tangent line here is going to go like this. A tangent line here is going to go like this. A tangent line here is going to go like this. But where will he have horizontal tangent lines? At the high places or the low places. Why might that be, interesting to look for? If we're looking for maxes and mins, that's important, right? To be able to find derivatives. So the horizontal tangent lines are going to tell me where my maximum points or minimum points are. Now, without the graph and further studies, okay, without the graph, we won't know which one's a max and which one's a min, but we will know that something important is happening there. And actually, in the next, I think it's the next chapter, I think it's in chapter 3, we actually start to use derivatives to find maxes and mins without using the graph, so you won't know what the graph looks like. We start using derivatives, and you can actually find which one is a maximum and which one's a minimum, okay? So we will eventually get there without using the graph, but what they're asking for on this one, horizontal tangent lines, it's saying like, where are the highs and lows, basically, is what's going on here, okay? So what I want to do is horizontal tangent line. I want to know if it has a horizontal tangent line, like this guy right here, the slope of that line is 0. So the slope slope of my tangent line is equal to 0. That's what I'm wanting to find. Well, what's another name for the slope of a tangent line? That's a derivative. I want to know where the derivative is equal to 0. So I'm going to take the derivative of this thing, and I'm going to set it equal to 0, right? So the derivative of that x cubed minus 3x plus 4, if you take the 3 and move it down in front, you're probably getting a little faster at this. 3x squared is what he will be, right? Minus the derivative of 3x is just 3, and the 4 is going to drop off, right? Because he doesn't have an x on him, okay? That's my derivative. I'm going to set that equal to 0, okay? Then we have to solve. So how do I solve that thing? He's not a trinomial. He only has an x here. So I'm going to toss this 3 to the other side. I'll zoom out if you're still writing, okay? Toss that 3 to the other side. So I have 3x squared equals 3, and then I'm going to divide by 3. So x squared equals 1, and then I take the square root. Okay, but since we put the square root in there, the square root of 1 is 1, but it's plus and minus 1, right? Does he have a horizontal tangent line at positive 1 on the x? Does he have a horizontal tangent line at negative 1 on the x? Yep, sure does. So that's how we can find those highs and low points. That's kind of like the magic of one of the really cool parts of like using derivatives. Set them equal to 0, then you can find your high and low points, right? That's example 7, okay? Now example 8, find the area of the triangle formed from the coordinate axis and the tangent line to the curve at the point 5, 0. I'm not sure if they, well, I already can see what the dimensions of that triangle will be, but we won't know that, right? Okay. All right. Well, I think what they want us to do is, let's go ahead and do this. Let's find the equation of this line right here, and then we can say that we graphed it, even though we already have the graph, and then we can find the area of that. All right. So I'm going to find the derivative of this guy, okay, because the slope of my tangent line, so if I'm trying to find the equation of this line, all right, I need to write him as y equals mx plus b, right? So I'm going to find the m first, and the m is the slope of my tangent line, true? Tangent line, okay, which is the derivative, right? M is the slope of a tangent line, which is the derivative, right? So I need to find the derivative of this thing and figure out what the slope is. So if I do his derivative, he's already ready to go for me. Like they made it nice. They made that x to the minus 1 power. So I bring the minus 1 down in front. It's going to be negative 5x to the negative 2 power, right? Minus, this is x to the first. The one's going to come down in front, so that's just 1/5 x to the 0, or just 1/5, okay? Now, I'm going to fix this. I'm going to move that x down to the bottom. So this is negative 5 over x squared minus 1/5, okay? Now, this is my derivative. That is the slope of my tangent line, except that's not a slope until I plug in this thing in, right? And really the 0 is just going to chill because the only thing I have to plug in is the x value right here, all right? So I have negative 5 over 5 squared minus 1/5, okay? 5 squared is 25, and 5 over 25 is 1/5. Minus another 1/5. That is negative 2/5. So I know that the slope right here, my y equals mx plus b, is negative 2/5 x plus b, right? Okay. All right, now this is the important part, because if I can find the b, which we already can see from the graph that it's going to be 2, but whatever. If we find the b, then we can know that it touches there, and then we can finish our triangle out, right? Okay, so I'm going to plug 5, 0 in and show you that 0 goes there. Negative 2/5 times 5 plus b. Negative 2/5 times 5 is going to be negative 2. But if I add the 2 over, my b is 2, just like we said it was going to be. And I have the equation of this tangent line is y equals negative 2/5 x plus 2. All right, so now we have that this dot is on 2, and we know this dot originally is at 5, 0. So now I can connect that line, which we already could see to begin with, but whatever, you won't have that on your homework assignment. And then I want to find the area of this triangle, right? The triangle, if we do the base of him, he is 5, the height of him is 2, and the area of a triangle is 1/2 the base times the height, or base times height divided by 2. If I take 2 times 5 and divide by 2, that is going to be 5 units squared. 5 units squared, okay? So that is that. That was kind of a weird way of asking us to write the equation of the tangent line, but that is that. Okay? All right, and then the last one, we will, at a certain point, I think the highest number of derivatives we go is 4, but they're just kind of showing you that like using them, like the highest number of derivatives we do that's useful is 4. Mainly the first 2 derivatives are the most useful, but you can continue taking derivative after derivative, and this just shows you kind of how this works. So what I want to do is I'm going to take the first derivative, which is f prime of x, right? The second derivative would be f double prime, okay? Now this is like easier than it sounds, all right? So if I take my first derivative, okay, 4 comes down in front, that is 12x cubed. Okay, minus 6x squared plus 2x, right? The 2 comes down in front, and he's just x, and then minus 4, and this 2 is going to drop off, right? That's my first derivative. Now, to find the second derivative, I take the derivative of this one, right? So now I'm like focused in on this one. The 3 is going to come down in front, that's 36x squared. The 2 is going to come down in front, that is minus 12x, plus the 1's going to come down in front, that's just 2, and the x is gone now, and this 4 drops off. Right? Now if I take the third derivative, I keep doing. 2 times 36 is 72, x to the first power, minus 12, 1 down in front, x to the 0 power, and the 2 drops off. Okay, the fourth derivative is going to be, this is to the first power, 1 times 72 is 72, the x drops off, but then the 12 drops off, right? But then what's the fifth derivative? How do I take the derivative of 72? Well, that's just a constant. It's going to drop off, and that's going to be 0. And anything after the fifth derivative is going to be 0, right? Because the derivative of 0 is 0. So eventually, after you take all these derivatives, it will end up dwindling down to nothing if it's a polynomial. If it's something like what we were doing here where we had like these powers and all this stuff, that's just going to keep getting uglier and uglier as we go through. But if it's a polynomial, it will end up dwindling to 0. And then, again, we won't usually ever use anything higher than the fourth derivative. Usually, like 2% of the time, we might use the fourth derivative. 98% of the time, we're only going to go to the second derivative, right? Because this is velocity and this is acceleration. We'll get to that when we start to do story problems. The third and fourth derivative are only used like to find very rare things, and I'll show you when those come. But it's just showing you the progression of like if you continue to take the derivative, it will end up dwindling to 0. So kind of fun. Anyway, there is that. Work on those homework problems. I don't care if you work together, that's fine. But there is that. Just try to get the rest of those done, and we will see you on Monday.